So when we look at the question, we have two parts. Part one, the coefficient of term x4 is equal to the coefficient of x power 6. Right? So we have to do one by one again. Coefficient of x4. Do the guess and check. What number of the R that produce the final answer of x power 4? That's right, A3. I just find the random number. 8 minus 3 is 5, right? 3. Okay, so focus on the expansion. The x power 3, x power negative 3. Is it producing x power 4? No, it is x power 2. So the 3 is rejected. Now 2. Okay, I want to decrease because I want to make this more, right? So 8 minus 2 is 6, right? Because the rules, 8 minus 2, and this is 2. Okay, we get it. So why we get it, why I can be so sure about that, because x power 6 and x power negative 2 is x power 4, right? So 8C2 using your calculator, 3 power 6. Wait, I don't have to rewrite the bracket. Yep, 3 power 6, x power 6, p square, x power negative 2, right? And we get the temporary answer, right? So 8C2, write it down, 28. 3 power 6, I don't care. Just write 3 power 6. Why? Because we are not finding the final answer of this part. P square and x power 6 and x power negative 2 is x power 4. Oh, okay, as expected, right? See? So the coefficient of x power 4 is this. Okay. So for part 1, we're done. And then equals to, see, equals to part 2, the coefficient of x power 6. You are finding now the coefficient of x power 6. So 8 something, and then 3x something, px negative 1, wait, power negative 1 something, supposed to be x power 6. Right? So again, you do the guess and check one more time. Okay, x power 6. Okay, I want to, oh, 81. I just get it. Why? Because as you can see, if 82, x power 4. So 81, I want to decrease the value of r, so I increase this, the left side. So 7, 8 minus 1 is 7, and then this is 1. See, quite simple. And you will get the answer right now. So 8C1 times 3 power 7. I don't want to deal with 3 power 7. It will be so much. It will be thousands or 10,000s of something. X power 7, and then p, and x power negative 1, right? And then the answer will be, okay, 8C1 using your calculator again. 8C1. 8. Oh, okay, nice. Simple. Times 3 power 7 times p times x power 6. We do the same pattern with the first part, but we deal with the different term. This is term x power 6. On the left side is term of x power 4. So this will be the coefficient of x power 6, right? Okay, and they say, the question said it is equal. So if it is equal, just equalize the number. As simple as that. 28 times 3 power 6 times p square equals, right, this 8 times 3 power 7 times p. And then how do you calculate the p? Find p. Okay, just move p on one side. I move p to the left side. P square over p equals 8 times 3 power 7 over 28 times 3 power 6, right? And then I can cross this. 3 power 7 and 3 power 6 becomes 3 power 1. And then 8 and 28, I want to divide by 4. I don't want to use calculator. No, 28. Oh, yes, I can. So the answer will be 2 times 3, 6 over 7. That's it. So P equals 6 out of 7. This is quite much. the logic is so hard to be understood, but we did this. Okay. Next question. So let's see for the wait for the question. Oh, I mean for the topics that we need to learn. Functions, quadratics, and straight line. Okay. Functions, quadratic, and straight line are quite simple. I just want to pick the hardest question on your book. Wait, I'm accessing your book right now. Drills and tasks, math. Wait. Is it better for you to see this bigger screen, bigger? I mean, bigger resolution rather than notebook, right? Wait, IB. Yeah, wait, IGCSE 0606. Now we deal with the functions. I am opening the file right now. Give me a moment. Okay. So let's start from the review set. Okay, we have to determine which is the relation, which is the function. Okay. Oh, it's bigger screen. I like this. So let's see. How do you do this? Remember, you have to deal with the vertical test. Remember, vertical test. If they have 2 points at one part, it is not a function. It's a pure relation. For A, it is a function. Why? Because when we do the vertical test, we don't have the same value of x, right? So everything is unique. Unique x. Okay, this is a function. And how about B? Of course, it's a function as well, because we do the vertical test. Have you ever taught by your teacher about the vertical test? I think so. Yeah. C, not a function. Why? If I do the vertical test, okay, I got 2 parts, 2 x's, and it is what do you call it? It is not following the rules of function. This function, as you can see, if you do the vertical test, the x is always same, right? I think I don't have to explain you much about this because I have to go further. We still have much to do. Okay, solve for x. Okay, if we have the number 3, yeah. Oh, number 2. Number 2 is quite interesting because we deal with we deal with the extra topics, integrated topics. Fx equals ax plus b, right? Fx equals ax plus b. It's given f1 equals 7, so f1 a times 1 plus b is equal to 7, right? And f3 is a times 3 plus b equals -5. So in order to solve a and b, you have to do the elimination formula, right? So a plus b equals 7, simplify. 3a plus b equals -5. This is the simultaneous linear equation, remember? So you have to do the, what I want to say. Wait, I lost my word. Oh, elimination. I eliminate this b. So a minus 3a is -2a. 7 minus -5 is 12. So the a will be 12 over -2. It is -6. And how do you get b? Okay, just substitute. -7 plus b equals 7, b equals 13, right? So because 7 plus 6. Piece of cake, right? So that's a and b. And this number 3 is, what's the difference between the other number of with number 3? We have the absolute sign, right? So when it is absolute, what you need to do is try to get rid of the absolute. Here, 3a. I will give you the easiest one. So x minus 5 can be either 7 or -7, right? X minus 5 equals 7. X minus 5 equals -7. How can it be? That's the question. That's my question for the second part. The first part, okay, we can do this. This is quite simple. You just ignore the absolute sign. But how to do on the right side? Why it has to be -7? Because the nature of absolute value is always positive. So if I insist to put -7 inside the absolute sign, it will also 7, right? So this can be -7 as well. Get it? So I think I explained it well about this. On the left side, I think it's quite simple. No need to explain far about that. So we have two possibilities. So x can be 12 or x can be -2. Okay. If I put x as 12, okay, piece of cake, 7. Absolute of 7 is 7. But how can I so sure about -2? Because -2 minus 5 is -7, right? The absolute of -7 is 7 as well. That's it. But how to do B? Both of the sides were negative, right? Were absolute. When both of the sides were absolute, I think I can give you this. So let's say this is positive. Okay. And then this is positive also. So 2x plus 1 equals x minus 4, right? Wait, it is 5 equals x minus 4. This is the first possibility. The second possibility, it can be negative, plus and minus, right? So we have 4 possibilities, by the way, right? So plus, plus minus, and then minus plus, and minus minus. 4 possibilities should be written. But if you think this is too much, I have another solution. What is the other solution? The other solution is just square both sides, and we've done for all parts. Why I have to square both sides? Because anything that is squared is always providing the positive answer. Okay, any number that is squared always providing the positive answer. 2x plus 1 square equals x minus 4 squared. So you don't have to think about which one is plus, which one is negative, wasting time. This will be saving time because we learned the quadratics after this. Okay, this is quadratics already. Oh, no, functions. Okay, functions to go to the quadratic part. So for x squared, I just expand it directly, equals x squared minus 8x plus 16. Okay, go to the left, move everything to the left, 3x squared plus 12x minus 15 equals 0. Okay, it's simplified. It can be simplified. X squared plus 4x minus 5 equals to 0. Just do the factorization part, right? So x could be plus 5 and x minus 1. That's it. So -5 or 1. Done for part 3, part B. Okay. Now for part 4 is also simple. Number 4, G2. Put the x by -2, right? So G of -2, sorry, I just said G2, G -2. So equals to -2 squared minus 3 times -2. So 4 plus 6, 10, done. How about x plus 1? Just write it down. G x plus 1 equals, the x becomes x plus 1. You treat the x as x plus 1. Minus 3, x plus 1, right? So x squared plus 2x plus 1 minus 3x minus 3. And it is in terms of x, no problem. Don't care about, it has to be number, no. It can be in terms of x, okay? Now, number 5. Domain and range. What is domain? Domain is the x, range is the y. But we have to understand, we need to understand about what? About the nature of the curve. If we have the point here on the left side, as you can see here, it is the ray. What is ray? Has its start, no end, with no end. So it's start to infinity to the right, or start to infinity to the left, up to you. Okay, so we can understand the domain start from -3. That's all. So the domain is x is more than equals to -3. Okay, we have bold part. It's full. When it is not full, so no equal sign. And the range will be y and go up, right? 2 and go up cannot be less than 2. So y is more than equals to 2. How about B? Part B. The domain is from infinity, from negative infinity, left infinity to the right infinity. So we can write that the domain is x of element real. Okay. And the range, the y minimum is -5, right? Y is always more than or equal to -5. It cannot be less than -5, right? See, if you look at the pattern of the graph, the curve can be lower than -5. So that's the range. Now, see, we have the, in this case, we have two parts. When x is less than -1, right? When x is less than or equal to -1, the y or the domain is equals to -3, right? This is the first condition. And the second condition, so you have to write it twice. When x is more than -1, why I don't put the equal sign? Because it is empty. See, when x more than -1, the y is equals to 1. That's how you think of number. Okay, the domain and range, I mean. And determine whether the function is 1 to 1. Yes, for part 1, this is 1 to 1 because 1y to 1x. Every y has specific x. Sorry, every x has specific y. But in this case, this is not 1 to 1. Why? Because we have 1y for two values of y. Sorry, one y two values of x, right? So not 1 to 1. Here, I think I will give you the simple speed. 1 to 1 means if you do the vertical test and horizontal test, and you still get the same, the exact unique. See, if you do vertical test, everything is vertical test done, right? But if you do the horizontal test, everything is also unique as well. In this case, vertical test pass is a function, right, on the B. But for the horizontal test, it's not passing 1 to 1. So 1 to 1 is always focusing on horizontal and vertical test. I think your teacher don't teach you this, but I hope this will give you give you an extra understanding, so it's more simple to understand. This not 1 to 1. Why? Because horizontal test, see, everything is here, but for the vertical test, it's a function. Okay, not 1 to 1. Quite simple. Next. Okay. How do you draw the graph of absolute? Okay, to draw the graph of absolute, you have to absolutize the negative. That's it. Absolutize the y negative because the y cannot be negative. So we have negative y here. How do you absolutize? By reflecting with x-axis. Okay, reflection of x-axis for the negative part only. In this case, you don't have to do this because it will be negative, right? So this part will be, wait, I will erase this. So this will be like this. Okay, ignore, and this will be like this. Ignore. So the function will be roughly like this, girls. See, wait, like this, right? And then this. Okay, like oh, like a Batman cape. Okay, continue. How about this? Okay, we deal with this. Done, right? Sorry for the bad drawing, but this will be explained a lot about the absolute part. Okay, go next. Okay, Okay, inverse. Do you know what is inverse? Oh, number 9. I will show you this. I think we don't have enough time to do the quadratics, but the quadratic is more simple because it's nearer to to the explanation of your teacher, right? So I will focusing on the functions. Okay, what is fgx? Fgx is the composite function. So if we have the two numbers here or two variables here, it is called the composite function. Okay, what is composite function? Function inside function. So if fgx, it means that we have the main value of f, main function of f, with the g inside. So I can write like this, f of gx, right? So if fx equals 2x minus 3, fgx is 2gx minus 3, right? Done. What is gx? Gx is given, so it's like an inception. What is inception? You put something inside something, right? So 2x squared plus 2 minus 3, right? Done. 2x squared plus 4 minus 3. So 2x squared plus 1. That's the value of a in terms of x. Okay, done. Next, b, g of x. That's more complicated. So g of x, also a composite function. And then g of fx, right? So if gx equals x squared plus 2, g of fx is fx square. Pay attention on the details, plus 2. So what is fx? 2x minus 3 square plus 2. Okay, do it one by one. 4x squared expand minus 12x plus 9 plus 2. Right, so 4x squared minus 12x plus 11. This will be the composite function on composite logic on the functions. And then we deal with the inverse right now. So next, how do we deal with the inverse? Inverse is you change the x by y and y by x. So for number 10, as simple as this, you reflect the curve or line by x equals y. The line of x equals y is located here. It is consistently same. There you go. Okay, it's 2 line. I just use the color. There you go. There you go. Right? Y equals x is like that. As always, 45 degree. And then the curve will be like this. So you reflect all the line or curve due respect to y equals x. So this will be your curve. This will be your curve. I have to be very, very careful. There you go. Right? So this is the inverse function of x. This is the inverse function of x. -1. And this also, okay, it's more complicated, but bang. Right? This is the inverse function of x. Okay. I think I need to copy this. So due respect to y equals x. That's how you do the inverse. But this is the graph. Okay, graph is quite simple, but how do you do the equation? Okay, I think I need to do all. 11, 12, 13. Again, inverse is when x equals y and y equals x. Y is represented by fx. Okay, let's try number 11. I can do it here, I think. Okay, so fx is y, right? I just changed y. See? So y equals 4x plus 2. And to calculate the inverse, you have to find x equals. So 4x equals y minus 2, right? And then x equals y minus 2 over 4. This is the implicit function of inverse. Okay, so what is the inverse then? After you find x as a subject, change f inverse x equals change to y by x. That's it. Okay, that's the number. That's the function, the inverse function of 4x plus 2. Next, how about this? Okay, it's more complicated, but because it's a fraction, but I don't think it's too complicated because you can do the cross multiplication. 4y equals 3 minus 5x. You can change the 5x to the left side because we are finding the x, not y anymore. Negative 4y plus 3. So x equals, see, negative 4y plus 3 over 5. So it is almost done. You have to change the x by inverse x, negative 4x plus 3, and y as x. You just change the x by y. That's it. Number 2. 12, I mean. I just read it one more time. Okay. So show that x equals f negative 3 equals g negative 4 over 3. I think we can do this. I don't want to do this. Just focus f3, 9, right? F negative 3 is 9. G 4 over 3 is 9 also. Okay, don't think about that. Finds x. Oh, find FOG2. Okay, so part B is quite simple. A, do it yourself. FOG, f of gx, right? So if fx equals x squared, fgx equals gx squared. So 1 minus 6x bracket square. But we have the number, negative 2. Oh, man, it's quite simple. So you don't have to expand, but just put it there like this. Wait, it's negative 2. See, no need to expand in terms of x, wasting time. 1 plus 12 bracket square, 169, right? 13. How to do C? Find x such gx equals f5. So gx equals f5. So what is gx? 1 minus 6x. What is f5? 5 squared, right? No, it's not hard. So something equals 6x. So 1 minus 25, right? Because 5 squared is 25, put to the left side becomes negative. So the x will be negative 4. Oh, okay, it's quite simple. Now, number 13 is very hard. Why? Because we have to find the inverse of each f inverse, h inverse. Okay, so for number 13, I just write down fx equals 3x plus 6 and hx equals x over 3.
Hey, Gohan.
Yes?
I'm still a bit slow on how to understand like the f of g of x thing.
Okay. Here, good. Now, if I have another question here. So fx equals 2x minus 3. And I have gx, it is 4 minus x, for example. I just make a simple one. How do you calculate fgx? Fgx is the composite function. You treat the g inside f, right? So fgx is f, do it vertical alignment, right? So if I have fx equals 2x minus 3, so fgx is 2gx minus 3. Get it, Vicky?
Yes.
X becomes gx, x becomes gx in this part. As vice versa, if I want to do g of x, I put f inside g. So we deal with this. So if gx equals 4 minus x, so g of x equals 4 minus fx, right? Because x becomes x, fx becomes fx. Okay, composite means function inside the function. How's it, Vicky?
So f of g of x is basically putting the g inside the fx.
F of g, yeah. Yep. Putting here, f of g means putting g inside of f. Okay. I will send you the video so you can watch it later. The other video that will explain a lot of this. Okay. Focusing on the composite function. Okay, so now inverse of f, do it one by one. You have to find one by one. So let's say this is y equals 3x plus 6. 3x equals y minus 6. X equals y minus 6 over 3. So f inverse of x equals x minus 6 over 3, right? Just switch it. F inverse done. And how about h? Y equals x over 3. cross multiply 3y equals x. Oh, done. X equals 3y then. So h, not f anymore. Careful. 3x, right? You just switch it. So this is the function, and function inverse of h inverse. What the heck is this? So function inverse of h inverse x, right? What is this? You have to put, as Vicky said just now, you have to put h inverse x in the f inverse. So h inverse x subtract 6/3. Use this one, right? And then h inverse x will be 3x. See, just switch this by 3x minus 6/3. Oh, we can factorize over 3. So x minus 2. Compare with the right side. HOF inverse. Okay, what is HOF first? Here, right? Ooh. One by one. Don't deal with the inverse first. Slowly, pelan-pelan. H of f means f x over 3, right? 3x plus 6/3, right? Because fx is 3x plus 6, and then you can get rid of the 3, x plus 2/3, cross. H of fx is x plus 2. It is not done yet because you want to find that inverse, right? The inverse. So let's say y equals x plus 2. Okay, what is x? Okay, piece of cake. Y minus 2. So x equals x, where x equals y minus 2. And the inverse of this, HOF, inverse of x will be x minus 2. Proven. See? This is so algebra. This is pure algebra, girls. So I hope your teacher won't give you this. We have to prepare for the worst, of course. Okay. So for the rest 5 minutes, I will show you. Okay, we're done. We deal with the quadratic right now. I put 4 and then go back. This is quite simple. I will give you the basics for quadratic rules or the formula. So quadratics can be written as function of x equals ax squared plus bx plus c. So we deal with the a, where a is positive, it is smiling, it producing the minimum axis, minimum vertex. If a is negative, it's frown, it producing maximum, right? Maximum vertex. B, nothing to do with that. C is the y-intercept. C is always the y-intercept, always. And we deal with problem right now. So when d equals 0, what is b? Determinant or discriminant? B squared minus 4ac can be written as d. So we have 3 possibilities where d more than 0, more means positive. So it cuts x-axis at 2 points. When d less than 0, wait, equals first, tangent, so touch x-axis. If it is touch, of course, at 1 point only. Okay. When d is less than 0, it fly or sink below. Fly or sink. Wait, what means by fly or sink? Okay, I think it can be above x-axis. Smile, there you go, right? Or below x-axis. Depend on a, right? This will be depend on a. Okay, I just give you the super simple explanation. It won't be much. You have to learn it on your own. But again, I will provide you the sources of learning quadratics later on. Okay, and then vertex. Vertex formula. What is vertex? The maximum or minimum point. Okay, vertex can be written as xm You use xp might be, but I use xm. Negative b over 2a, either negative or positive is the same, and ym equals d over negative 4a. Okay, that's how you do the vertex. And what else? X-intercept. X-intercept is where y equals 0. Memorize this basic rule because it touched the x-axis, so no y at all. And the y-intercept is where x equals to 0. Okay, so this is the basics. Again, this is oversimplified and understanding. Okay, so later on we will I will explain you how to do this. Okay, tomorrow. Okay, for the next meeting. But I think you can watch my video. I forgot where the video is recorded when, but I think you can find it on your own. Okay, so today we done with 3 parts: quadratics, search indices, and binomial expansion. Binomial expansion is for on the we learn by answering the question. Okay, I will stop the sharing. I will send the files to you, the documents on PDF. I hope you understand. So do you have any questions so far? We still have 2 minutes. I don't think one question can be done right now. Any questions so far, girls?
No.
So please watch the video, because the video is, yeah, I think it will help you a bit